Okay, welcome to this week's episode of Luv Subbin, and this week we're going to be talking about my Hughes Autoformer.
That's right, we talked about this in our video when we did the electric and the water hookups. So we got a couple requests from viewers.
Yep.
That we discussed this a little further, so that's what we're going to do.
For us, we use this primarily as a surge and spike protection, but what it does is it also boosts voltage. And therein lies the big controversy, because the NFPA, the National Fire Protection Agency, they've got a proposal out there that people think, some think,
might apply to this.
Right, and we're going to talk about that towards the end of this video.
Yep.
And like here on Luv Subbin, we're going to apply math and science, and not speculation, to the Hughes Autoformer, which, by the way, weighs a ton. But we're going to explain that. Should
be interesting.
Stay tuned. All right, let's go ahead and start with our cast of characters. The first is Georg Ohms with Ohm's Law, V equals IR. Coming up next is James Watt, who established the relationship of power, voltage times amps. And hey, how about a Luv Subbin bonus? You're probably thinking, hey, volts are W, resistance is R, why is amps I? Well, that's because Andre Marie Ampere named it Intensité du Courant, or intensity of current. Okay, our final cast of character is Michael Faraday, and he came up with the Faraday's Law of Induction. And this is one of the most important parts of understanding how an autoformer works and how it's different than, say, just water through a pipe type of thing. So he came up with the following thing, and this is going to show basically the guts and the inside of our autoformer. Okay, so what Faraday's Law of Induction talks about is it talks about basically how a transformer works. And if you think about transformers, we see them throughout our infrastructure, because in order to transport electricity long distances, you have to have very, very high voltage. And that very high voltage is transformed into lower voltage that we can use in our homes by changing the voltage and amperage relationship. So what Faraday found is when you put a wire with alternating current only into a coil, it forms a electromagnetic field. Okay, so if you were to put that electromagnetic field and that coiled wire onto a iron core, you can then create a magnetic flux. So we have an input, two wires here, and let's just say we put a few wraps onto this iron core here.
Wraps of what?
Copper wire. And we put a bunch of wraps on there. And now we're forming a magnetic flux around that iron core. Flows in that direction. Now the cool thing that is just, to me, unbelievable is that if you have another series of wraps, so this is the primary winding, this is the secondary winding, and it has fewer wraps than the primary. The voltage here is going to be a lot less than the voltage here. And it's actually directly proportional. So if we have voltage 1, voltage 2, in this particular scenario, voltage 1 is going to be greater than voltage 2, and it's directly proportional. So let's say I have 1,100 wraps here and 1,000 wraps here. My voltage is going to be 10% lower, and my amperage and it's directly proportional to the number of wraps. Let's take this next example here. This is how the autoformer works. You're going to take a series of wraps. And in an exaggerated sense, you'll then create that magnetic flux. You'll have V3. And here we're going to have so in this particular example, we'll have 1,000 wraps. In this particular example, on the secondary winding, we'll have 1,100. V3 is going to be less than V4 by 10%. So my volts will be up 10% and my amps will be down 10%. I mean, whoever thought of this, it's so cool that it's so directly proportional, but this is an important thing to remember when you talk about the amperage and the voltage and the relationship as to how an autoformer can boost voltage. It's not doing it by stealing voltage anywhere. It's not doing it by taking voltage. It's not a power generator. It's not a power distributor, but it is a power transformer. So I'm just through magnetic flux and induction of voltages, that's how I'm changing the voltage. Now that we have a basic understanding of how the autoformer works, let's go ahead and take a look at a couple of examples here. So here in the RV, you've got basically two types of electrical load. You've got the inductive and the resistive. The inductive is basically things that turn motors, okay? Things like your air conditioner, your fridge, your fans, all that stuff. And it's really the vast majority of juice that's used in your RV. The resistive loads are things like incandescent light bulbs. I still haven't figured out if LEDs are a resistive load or not. I think they are, but they definitely use less power. The Instapot and coffee maker. For the purpose of this example, to keep things simple, we're going to talk about using your air conditioner and your Instapot. Based on some of the formulas that we use from our cast of characters, we can see that there's two different types of loads in your RV. There's the inductive, as we talked about previously, and the resistive. And we're going to calculate current usage differently for each of them. The first is the inductive, which just basically turns motors. We're going to divide
like your air conditioner.
Yeah, exactly. We'll divide the power by the voltage using the watts formula. For the resistive, we're going to use Ohm's formula, and the current is going to be the voltage divided by the resistance. Okay? Now remember we said we were going to use our Instapot. And for the Instapot, we're going to have to do a couple other calculations because we don't have that R.
That's an example of the resistive.
Yes, and that's the Instapot. So if you looked at the back of the label on the Instapot, you can see that its rated power is 700 watts at 120 volts. So we can figure out easily the amperage from that. Amps equals watts over voltage, 700 over 120. So we're pulling 5.83 amps with the Instapot. Then using Ohm's law, volts equals IR, resistance equals voltage over amperage, 120 over 5.83, and we'll find that the resistance of the Instapot is 20.6 ohms, and we're going to be using that in our calculations. All right, let's start off with Happy Camp. We've got two sites that we see here. Both sites have 120 volts, good voltage, 30 amps, so the power available at that pedestal is 3,600 watts. So let's talk about our air conditioner. We're running that at 1500. That's basically the Penguin air conditioner that I have on my RV. 1500 watts at 120, so it's pulling 12.5 amps. The Instapot, 120 volts over the 20.6 ohms, it's pulling 5.8 amps, which you may recall from the previous slide, we showed that. So that's Happy Camp. We're both pulling exactly, if you add those up, 18.3 amps. Okay?
That's running the Instapot and the air conditioner.
Just as an example. Yeah, you might be running different loads and you can add them all up, but now let's go put in my site 1 has an autoformer. So we're going to hook up our autoformer because we're at Sad Camp now. And you can see Sad Camp is running 108 volts at 30 amps. So its available power that pedestal can deliver is 3,240 watts.
So the amps stay the same no matter what?
Yeah, because you can pull up to 30 amps and then your breaker will break.
Okay.
Okay. So now site 1 is going to hook up their autoformer. Okay. So the autoformer is going to recognize that the voltage is low and it's going to boost that voltage to 118.8. However, as we found, that 10% increase in voltage is going to result in a 10% decrease in amperage. Okay. The power available is still the same, but now I only have 27 amps that I can pull. I will note, however, that the autoformer does have some energy loss in the form of heat and impedance and things like that, so it draws my 30 amp about 0.6 amps, and we'll include that in the calculations. All right, so here's the biggie. Let's take a look at what our air conditioner is doing. 1500 watt power air conditioner. We're going to run it on 118.8 volts. It's going to draw 12.6 amps. Site 2, however, 1500 watts. He or she's only getting 108 volts. So they're going to pull 13.9 amps. And that's the real thing for the autoformers. It's not so much to be able to steal power or to run power when others can't, but it's to protect your sensitive equipment, because now you're going to be pulling more amps. You're going to be generating greater heat.
That's not good for motors.
And it's not good for motors, and you could wear motors out if you're continuously using them at an amperage higher than what it's rated for. So the autoformer is really protecting your sensitive equipment. Okay? Now the Instapower, it's going to operate just a little bit differently. Okay? So in this case, the person with the autoformer is going to be drawing more current because the relationship of voltage and resistance. So at 118.8 volts and 20.6 amps, or 20.6 ohms, I'm going to pull 5.8 amps, whereby my neighbor at 108 volts is going to pull only 5.2 amps. Okay, but remember, that means he's also going to have to, he or she's going to have to operate their coffee maker maybe a little bit longer, or their Instapot maybe a little bit longer to get that same amount of energy. Because
who does? The autoformer person, or
no, the person, because they're only getting less juice, you could say.
Oh, so they're not getting enough amps to.
Right. So their energy, for example, their coffee's not getting as hot, so it may have to go a little bit longer. Yep. So you may have to run it just a little bit longer. So if we look at these two situations,
so the autoformer is helping in that situation as well, a little bit.
It can be, it's dependent. Yes, in this case, the autoformer is pulling 0.6 amps more than the person without the autoformer. Of course, it's pulling a lot less, 1.3 amps less on the air conditioner. So, you know, everybody says it's stressing the campground. Is 0.6 amps really going to stress the campground? Especially when you add up the total, the person with the autoformer total is pulling 19 amps, and the person without the autoformer is pulling 19.1 amps. So it's kind of a wash, and that includes the 0.6 as I said before. So you may be asking yourself, why is there so much confusion with the autoformer? Why do so many people think it steals power or it robs power? Well, I have a theory on that, and it has something to do with this. The water hose. You may recall your high school physics class, and they use the analogy to describe electricity, because it's hard to see, that volts are the pressure in a water hose and current is the flow through that water hose. Well, I think people are continuing that thought process, and they're thinking, well, if I need more pressure, I'm going to get a bigger pump, and that pump is the autoformer. And if I'm pumping more water, well, then I've got to be taking it from the guy next to me, or I've got to be using more water from the campground. But as we saw with Faraday's law of induction, it just doesn't work like that. So electricity is a little bit different, and I think that's kind of why people think that this is not right. So finally, why would the NFPA be trying to ban an autoformer? Well, when it comes right down to it, they're not trying to ban autoformers. They're trying to ban automatic transformers, and the two are very different devices. An automatic transformer has a single winding and a common neutral, okay? So it's cheaper, but it can be a little bit more dangerous if certain faults occur because they're not isolated. The two windings are not isolated. They use kind of one doing dual service. Robert Hughes was probably, in hindsight, a better engineer than he was a marketer, and he's probably wooing the day he called it an autoformer, being so similar to an automatic transformer, because it's clear that the Hughes Autoformer has 4 windings, 2 primary, 2 secondary. I've got their patent right here, as well as the schematic for what makes up a Hughes Autoformer, and you can clearly see that it has 4 windings in it, and it is not an automatic transformer, which is what the NFPA does identify as being dangerous and is trying to ban. It's not going to be the Hughes Autoformer. Well, I hope you enjoyed that video and learned something about what an autoformer is and what an autoformer is not.
I'm not sure I learned anything, but I learned I probably shouldn't run my hairdryer with my air conditioning going.
Probably a good point. The important thing is to make sure you have surge protection for your RV, whether you decide to go with an autoformer or not.
If you like this video, give us a big thumbs up.
Click the subscribe if you haven't already.
And comment below if you have an autoformer or if you have more questions about an autoformer.
Yeah, we'll actually have a link to our Amazon store for the autoformer if you kind of think it's something you'd want to get. Doesn't cost you anything and it helps the channel.
Doesn't cost you anything more.
Correct. Yeah, it does cost you a whole boatload. These things are like $500, so.
Doesn't cost you anything more to use our link
right.
though.
We come out with RV and Airstream related content every Tuesday.
Yep, and thanks for watching.